Alright, silly people, here's the situation. We're going to be calculating um, some forms for Hermite polynomials using various different formulas. Starting with using the Rodriguez formula to calculate H3 and H4. So let's start with H3. Um, minus 1 to the third is just minus 1. You have e to the x squared. You're doing the third derivative with respect to x of e to the minus x squared, which is minus e to the x squared times the second derivative with respect to x of minus 2x e to the minus x squared, which is minus e to the x squared times the second derivative with respect, times the first derivative with respect to x of minus 2x squared times e to the minus x squared minus 2e to the minus x squared, which is, I'm going to simplify that a little bit, doing the first derivative of 4x squared times e to the minus x squared minus 2e to the minus x squared. So minus e to the x squared d dx of 4x squared minus 2 of, times e to the minus x squared. Then actually do the derivative, so minus e to the x squared, and then it's 4x squared minus 2 times negative 2x times e to the minus x squared so plus 8x times e to the minus x squared. And then, so the e to the x squared on the outside cancels out the negative ones on the inside, so you have minus minus 8x cubed plus 4x plus 8x, right? So it's it's 8x cubed minus 12x, and I think that is the right one. Yeah, it is. Okay, that was H3. Let's do H4, which is going to be, now it's minus 1 to the fourth, so it's just positive 1, e to the x squared, and then the fourth derivative with respect to x of e to the minus x squared, which, to be fair, is just the derivative with respect to x of the third derivative with respect to x of e to the minus x squared. And we already calculated what that is. It was just e to the x squared, and then this was the first derivative of, what did I have there? Minus 8x cubed plus 12x. Both of those should be multiplied by e to the minus x squared. So doing the derivative of that, you'll get minus 8x cubed plus 12x times minus 2x times e to the minus x squared plus, now it's minus 24x cubed plus 12. So that's bx squared times e to the minus x squared. And then again, the positive one on the outside cancels out the negative ones on the inside. And then so you'll have 16x fourth minus 24x squared minus another 24x squared plus 12, which gives 16x fourth minus 48x squared plus 12. All right, then the next bit of the problem is to find out what h5 and h6 is using the recursion formula, which is given by hn plus 1 of x is equal to 2x hn of x minus 2n hn minus 1 of x. So starting with h5, so n is going to have to be equal to 4. You'll have it's 2x h4 minus 8. 2 times 4 is 8 h3. So we're doing 2x times 16x fourth minus 24x squared minus 48 x squared plus 12 minus 8 times 8x cubed minus 12x. So 32x fifth minus 96x third plus 24x minus 64x cubed minus 96x, or plus 96x. So 32x fifth, and then 96 plus 64 is 160, 160x cubed, and then 120x. Then h5 will be, oh no, well, that was h5. We need h. That was h5. We need h6, which is going to be 2x times h5 minus 10h4. So 2x times 32x fifth minus 160 x cubed plus 120x minus 10 times 16x fourth minus 48x squared plus 12. So 64 x sixth minus 320 x fourth plus 240 x squared minus 160 x fourth plus 480 x squared minus 120. So we get to keep 64x sixth. 320 plus 160 is like, is that 580? No, it's 480. Minus 480x fourth, and then 240 plus 480 is that 720? So 720, whoops, x squared minus 120. I think that's right. Next bit is to find h, or check h5 and h6 using this formula, where dhn with respect to x is going to be equal to 2n times hn minus 1. So, and we're supposed to use that to check 6 and 5. So let's look at 6 first. dh6 dx is going to be 64 times 6 x fifth minus 480 times 4x third plus 720 times 2x. And then presumably we'll be able to factor out a 2 from all of that, so we can do just 2 times 32 times 6x fifth minus 240 times 4x cubed plus 720x. And then also presumably we'll be able to factor out 6 from all that. So 2 times 6, which is n, by the way, So 32x fifth minus 40 times 4? No, 4 times 4. No, it's 40 times 4. X cubed plus 120x. And then simplifying what's inside here, that's going to be 160x cubed plus 120x, which is 2 times 6 times h5. Checks out. Let's do then the derivative of h5 with respect to x. So that's going to be 32 times 5 times x fourth minus 160 times 3x squared plus 120. Presumably we can factor out a 2, so let's do 2 times 16 times 5x fourth minus 80 times 3x squared plus 60. I don't know, we get to factor out a 5. So 2 times 5 times 16x fourth. 16 times 3x squared plus 12. So 2 times 5 times 16x fourth minus 48x squared plus 12. That is truly h4. So that works for me. The next and final part of this problem is to use the fact that hn will be the nth derivative with respect to z of the generating function e to the minus z squared plus 2zx, evaluated at the point z is equal to 0. And we're meant to find h1, h2, and h3 using that. So that's going to be, so h1 is the first derivative of e to the minus z squared plus 2zx, evaluated at z is equal to 0. So it's minus 2z plus 2x times e to the minus z squared plus 2zx, evaluated at z is equal to 0, which is going to give us just 2x. That's h1. h2 then will be the second derivative of the generating function with respect to z, evaluated at z is equal to 0. So it's going to be the first derivative with respect to z of minus 2z plus 2x times e to the minus z squared plus 2zx, evaluated at z is equal to 0. And then let's do it. So it's going to be minus 2z plus 2x squared times e to the minus z squared plus 2zx. And then minus 2 times e to the minus z squared plus 2zx, all evaluated at z is equal to 0. So you get 4x squared minus 2. That's h2. Finally, h3 is going to be the third derivative with respect to z of the generating function, evaluated at z equal to 0. So it's the second derivative. Actually, it's the first derivative of the second derivative So it's the first derivative of minus 2z plus 2x squared e to the minus z. Actually, yeah, let's leave it like that. Z squared plus 2zx minus 2 gross. Minus 2e to the minus z squared plus 2zx. Evaluated at z is equal to 0. So we're going to have a minus 2z plus 2x cubed e to the minus z squared plus 2zx plus a 2 times 2zx, or 2 times minus 2z plus 2x times minus 2 times e to the minus z squared plus 2zx, and a minus 2 times negative 2z plus 2x times e to the minus z squared plus 2zx. All of that evaluated at z equals 0, which is going to be 8x cubed plus 2 times 2x times minus 2 times 2x, which is 8x cubed plus, or minus 8x minus 4x. So 8x cubed minus 12x. I think that's right. It is.